This is a microchip. Specifically, it's a 3-nanometer processor manufactured by Taiwan Semiconductor Manufacturing Company in Tainan, Taiwan. It contains 50 billion transistors packed into a space smaller than your thumbnail. The machine that made this chip costs $380 million, weighs 180 tons, and can only be produced by one company on Earth, ASML, in the Netherlands. There are fewer than 100 of these machines in existence. This chip powers the device you're watching this on. It powers the servers running your bank. It powers the guidance systems on American missiles and the training clusters for artificial intelligence models that will reshape every industry within a decade. And right now, 92% of the world's advanced chips, everything below 7 nanometers, are manufactured on a single island, 110 miles from mainland China, that Beijing considers a renegade province. On January 14, 2026, TSMC's Arizona facility, the $40 billion project that was supposed to reduce American dependence on Taiwanese manufacturing, announced its third major delay. The 4-nanometer production line that was promised for 2024, then 2025, will now enter volume production no earlier than Q3 2027. The 3-nanometer facility has been pushed to 2029, and buried in the earnings call transcript is a single sentence that changes everything. Yield performance at Arizona remains below commercially viable thresholds. This is not a construction delay. This is a technological admission that the most sophisticated manufacturing process ever developed cannot be successfully transplanted from Taiwan to American soil. And when that reality becomes undeniable, the $1 trillion question of who controls the future of computing will have only one answer. Here's what they're not telling you. TSMC's Arizona project was announced in May 2020 as the crown jewel of American semiconductor independence. The plan was elegant. Bring Taiwan's manufacturing expertise to American soil, train American workers, and create a domestic supply chain that could survive a Chinese blockade or invasion of Taiwan. Congress allocated $52 billion through the CHIPS Act. Arizona provided $2 billion in tax incentives. Apple, AMD, and NVIDIA committed to purchasing Arizona-made chips at premium prices. The problem is that semiconductor manufacturing isn't a recipe you can photocopy. It's a living system of 1,500 discrete process steps, each calibrated to tolerances measured in individual atoms, performed by engineers who've spent decades learning to feel when something is wrong before instruments can detect it. TSMC's Taiwanese facilities achieve 90% yield rates on 3-nanometer chips, meaning 9 out of 10 chips work perfectly. The Arizona facility, after 3 years of operation, is running at 52%. At 52% yield, every working chip costs nearly twice as much to produce. At twice the cost, Arizona-made chips cannot compete with Taiwan-made chips on price. And without price competitiveness, the entire economic justification for the project collapses. At 9:15 a.m. Taipei time on January 7, 2026, TSMC's board of directors held a special session to review Arizona performance metrics. No public announcement was made, but within 72 hours, 3 board members with deep ties to the Taiwanese government sold significant portions of their personal TSMC holdings. Transactions that were disclosed in regulatory filings but not reported in any financial press. The official explanation for the yield gap is workforce training challenges. TSMC brought 500 senior engineers from Taiwan to Arizona to oversee operations. They've been there for 2 years. The American workers they're training have access to the same equipment, the same process documentation, the same everything. The yield gap hasn't closed. It's widened. There is something about the Arizona facility that prevents it from replicating Taiwan's results, and TSMC either doesn't know what it is or isn't saying. This is where the lie becomes unsustainable. Semiconductor manufacturing, at the leading edge, operates in a regime that engineers call process window, the narrow range of conditions under which fabrication succeeds. At 3 nanometers, that window is measured in angstroms, units 1/10,000,000th of a meter. The difference between a working chip and a paperweight can be a temperature variation of 0.1 degrees Celsius, a vibration frequency imperceptible to human senses, or a particle of contamination smaller than a virus. Taiwan's facilities have spent 30 years optimizing for these conditions. The buildings are constructed on bedrock, with vibration-damping foundations tuned to the specific resonance frequencies of EUV lithography equipment. The air filtration systems achieve Class 1 cleanroom standards, fewer than 1 particle per cubic foot of air. The water purification produces H2O so pure that it becomes corrosive, requiring specialized containment systems. The power grid has been hardened to eliminate voltage fluctuations that would be undetectable in any other industrial application. Arizona's facility was built to world-class specifications, but world-class is not Taiwan class. The Colorado River water that feeds the fab requires additional purification steps that add cost and introduce variability. The desert temperature swings stress HVAC systems in ways that Taiwan's subtropical climate does not. The power grid draws from a mix of sources with different harmonics than Taiwan's dedicated semiconductor power infrastructure. None of these factors individually explain the yield gap, but manufacturing at the atomic scale is a system where everything affects everything else. A 0.1% degradation across 1,500 process steps compounds to a 78% yield reduction. The Arizona facility isn't failing any single test. It's failing the integration test, the one that measures whether all the pieces work together at a level of precision that has never been achieved outside of Taiwan. Paper specifications cannot capture this knowledge. It lives in the hands of engineers who've been doing this for decades, and in the institutional memory of facilities that have evolved through millions of production cycles. When institutions do this, they're not managing risk, they're containing disaster. On December 18, 2025, the U.S. Department of Commerce convened an interagency task force on semiconductor supply chain resilience. The meeting was classified. No official readout was provided. But the attendance list, leaked to the South China Morning Post on January 2nd, included representatives from the National Security Council, the Defense Advanced Research Projects Agency, and the Office of the Director of National Intelligence. Commerce doesn't invite intelligence officials to discuss normal industrial policy. They invite them when a supply chain vulnerability becomes a national security emergency. 2 weeks later, Commerce Secretary Gina Raimondo announced expanded technical assistance programs for domestic semiconductor manufacturers, a $3 billion supplemental allocation that wasn't in any previous budget. The funding will support yield enhancement initiatives at Arizona and other domestic fabs. Translation: the government is throwing money at a problem that money cannot solve, because the alternative is admitting that the CHIPS Act has failed its core objective. Intel's Ohio facility, the other flagship of American semiconductor independence, has already been delayed from 2025 to 2028. Samsung's Texas expansion, originally projected for 2024, has been pushed to 2026, with no guarantees on yield performance. Every major reshoring initiative is following the same trajectory, announced with fanfare, delayed repeatedly, and quietly downgraded in scope. Less than 18 months remain before the 2027 window that military planners have identified as the period of maximum Taiwan Strait risk. If China moves on Taiwan before American domestic production reaches meaningful scale, the United States will face a strategic reality it hasn't confronted since World War II. Critical defense systems that cannot be manufactured without access to foreign facilities in a war zone. The F-35 fighter jet contains over 1,500 chips manufactured in Taiwan. The Javelin missile system, the weapon that proved decisive in Ukraine, requires Taiwanese semiconductors for its guidance systems. The server infrastructure running American military communications, logistics, and intelligence analysis depends on Taiwanese fabrication that cannot be replaced from domestic sources. The last time the United States faced a single point of failure this severe in a critical military supply chain was rubber in 1942. The response then was a crash program that invented synthetic rubber within 2 years. The difference now is that synthetic semiconductor manufacturing doesn't exist. You cannot invent your way around physics. While one side struggles, the other side advances. China's semiconductor strategy has evolved from imitation to innovation to something more dangerous: patient accumulation while the competition defeats itself. SMIC, Semiconductor Manufacturing International Corporation, achieved 7-nanometer production in August 2024, using equipment that Western export controls were supposed to make impossible. The process is less efficient than TSMC's. The yields are lower. The cost per chip is higher. None of that matters. What matters is that China demonstrated it can manufacture advanced semiconductors without Western equipment when sanctions make acquisition impossible. Huawei's Mate 60 Pro, released in August 2023, contained SMIC's 7-nanometer chip, a device that American analysts said couldn't exist for at least 5 more years. The phone was released during Commerce Secretary Raimondo's visit to Beijing, a timing choice that was not accidental. The message was clear: your sanctions delayed us. They did not stop us. On January 10, 2026, SMIC's Shenzhen facility filed environmental permits for a new production line with specifications consistent with 5-nanometer manufacturing. If accurate, this would represent a generational leap, achieved not by purchasing Western equipment, but by developing indigenous alternatives through a $150 billion government investment program that dwarfs the CHIPS Act by a factor of 3. The Chinese approach accepts that they will trail TSMC in absolute performance for years, possibly decades. But absolute performance is not what wins this race. What wins is manufacturing capacity at volumes sufficient to supply domestic demand, while the global market fragments into competing blocks. China consumes 35% of global semiconductor output, more than any other nation. If China can supply even half of that demand from domestic sources, it removes $180 billion in annual revenue from Western manufacturers, while building the production base to scale further. The 5-nanometer chips SMIC produces don't need to match TSMC's best. They need to be good enough for smartphones, servers, and military systems. And good enough is achievable on a timeline that world-leading is not. This is not about one company racing another. This is about whether the infrastructure of advanced computation remains globally integrated or fragments into spheres where geography determines capability. The mathematics of the trap are now inescapable. TSMC cannot solve the Arizona yield problem without revealing proprietary knowledge that makes Taiwan strategically indispensable. If TSMC teaches American workers everything needed to match Taiwanese yields, Taiwan loses its primary insurance policy against abandonment, the fact that the world needs Taiwan's chips too much to let China take the island. But if TSMC doesn't solve the yield problem, the CHIPS Act fails, American semiconductor independence remains a fantasy, and the strategic vulnerability persists. Taiwan's government understands this dynamic perfectly. On December 22, 2025, Taiwan's Ministry of Economic Affairs issued new guidelines restricting the transfer of advanced process knowledge to overseas facilities, including TSMC's own subsidiaries in Arizona. The guidelines were framed as intellectual property protection. The strategic intent is to ensure that the most valuable semiconductor expertise remains physically located on Taiwanese soil, where American security guarantees must be honored to access it. TSMC is trapped between two sovereigns making contradictory demands. The United States wants manufacturing independence from Taiwan. Taiwan wants manufacturing dependence on Taiwan. TSMC serves both masters and can fully satisfy neither. Meanwhile, every month of delay at Arizona is a month of additional production at TSMC's Taiwanese facilities. $20 billion in monthly revenue that flows to Taiwan, funds its military modernization, and deepens the dependency that the CHIPS Act was supposed to eliminate. The project designed to reduce American vulnerability is instead subsidizing the perpetuation of that vulnerability. This is what a system looks like when success and failure become indistinguishable. If Arizona succeeds, Taiwan becomes strategically expendable, and TSMC's home government loses its primary leverage over American policy. If Arizona fails, Taiwan remains indispensable, but America remains vulnerable to a Chinese military action that Taiwan cannot survive without American intervention. Either outcome accelerates toward instability. There is no path that preserves both American security and Taiwanese security simultaneously. The $40 billion already spent on Arizona cannot be recovered. The additional $20 billion required to reach volume production will be spent regardless of yield performance, because abandoning the project would publicly acknowledge strategic defeat. The CHIPS Act has become a sunk cost fallacy at national scale, a program that continues not because it's working, but because admitting it isn't working is politically impossible. China's optimal strategy is to do nothing. Every year that passes, Chinese domestic capabilities improve, while American reshoring efforts stall. Every yield report from Arizona strengthens the case for patient accumulation over forced timelines. And every dollar America spends failing to replicate Taiwanese manufacturing is a dollar not spent on the military capabilities that might actually deter Chinese action. The trap is self-tightening. The more America struggles, the more obvious the struggle becomes, and the more China can calculate that waiting is superior to acting. The informed are not waiting for official announcements to understand what's happening. TSMC's stock has declined 18% from its July 2025 peak, despite record revenue and profit. The decline reflects institutional investors pricing in geopolitical risk that earnings reports don't capture. The recognition that the world's most valuable technology company is located in the world's most dangerous flashpoint. NVIDIA has quietly secured manufacturing commitments from Samsung's Korean facilities as a backup to TSMC, a hedge against Taiwan disruption that was announced as capacity diversification, but internally framed as business continuity planning. Apple has accelerated M-series chip stockpiling, building inventory buffers that exceed normal supply chain practice by 40%. These are not routine procurement decisions. They are preparation for supply disruption that major customers consider plausible within their planning horizons. The Philadelphia Semiconductor Index has underperformed the S&P 500 by 12 percentage points since October 2025, despite AI demand driving record chip sales. The market is speaking clearly. Growth doesn't matter if the manufacturing base that enables growth might not exist in 3 years. Physical gold purchases by Taiwanese households have increased 65% year over year, according to the Taiwan Gold Association. Wealthy Taiwanese are converting financial assets into portable stores of value. The same behavior observed in Hong Kong before the 2020 security law, in Ukraine before the 2022 invasion, and in every jurisdiction where populations sense that paper wealth may not survive political discontinuity. The divergence between paper claims and physical reality has begun in semiconductors just as it has in precious metals. TSMC's market capitalization values the company at $600 billion. But if Taiwan becomes inaccessible, that $600 billion becomes zero, while the physical equipment in Taiwanese fabs becomes priceless to whoever controls it. The question is not whether the global semiconductor supply chain faces restructuring. The question is, who understands that restructuring well enough to position for its consequences? 50 billion transistors on a chip smaller than a fingernail. $380 million for a machine that prints with light at wavelengths the human eye cannot see. 30 years of accumulated knowledge that cannot be written down, only practiced. And all of it, every transistor, every machine, every engineer who knows how to make it work, sitting on an island that 2 nuclear powers consider non-negotiable. This is not a supply chain. This is a hostage situation where the hostage is the future of human computation. Physics doesn't negotiate. Manufacturing expertise doesn't transfer by legislation. And reality, eventually, asserts itself over every strategy that pretends otherwise. The divergence between Arizona's promises and Taiwan's production has begun. What happens next is not prediction. It's the gap between what we want to build and what we actually can.